Glad to be here. And in the next 30 minutes, I would like to take you guys into a very focused domain around app security. So I hope there's some mobile app developer here. Can I just have a show of hands? How many people actually develop and touch mobile apps? Okay, awesome. At least you guys will find it entertaining, and hopefully everyone else will also feel like, wow, I think I need to get into more on mobile. So a little bit about me. Studied and grew up in Australia, studying engineering, and it's quite boring because everything you do with hardware, once you build it, you can't change it, right? So I kind of moved into software, and then I joined one of the large telco here, and ultimately, jumping around because I wasn't a very good developer, so I got into consulting. So tip for you guys, if you guys ever want to, get into a vendor land, don't be too good at what you do. And then, I don't know if anyone knows about this company called CA Wiley or Wiley Technology. So it's actually the grandfather of observability. So it's the first product essentially on the market that monitors and does bytecode instrumentation of Java application, right? So all the New Relic, Dynatrace, App Dynamic, they all came from the same sort of family. So I was, one of the technical consultants for them. And then ultimately I got into security because I actually find, again, you don't need to be a very good developer. You can be a consultant, but security is actually very mind-blowing. And hopefully I can take you through that journey. So my mission in life is to protect one mobile devices at a time or one mobile app at a time. And hopefully by end of the session today, some of you will come to me and then we can talk a little bit more about how to protect your app. Now, where's the security in DevOps, right? There's two schools of thought, right? So there's the DevSecOps, and there's also the SecDevOps. How many of you does or you think you practice DevSecOps today? Is this something that, okay, great. Very brave lady. So I think over the last, I would say 3 to 4 years, right? We started with DevOps and then we started to look at, really a culture process change. And security was always on the side, right? Because I think I was talking to one of the security manager. Being a developer before, I know when the security guys comes and say, hey, you need to do this, you need to do that. I'm always like, you're gonna slow me down. I'm gonna talk to the business owner because the project is gonna get delayed. And in the end, there's a lot of discussion, argument, or heated, right? So I think over the last 3-4 years, I have seen a really good adoption of putting security or this notion of AppSec into the DevOps process, the pipeline. If you look at how many solution provider here, right, that sort of addresses that market. However, I think one thing that's important to call out is that I think there's too much emphasis on the pre-production, right? Let me give you an analogy, right? You go to a hospital, you scan for yourself, you do X-ray, you do blood tests, you do all that stuff. The result come back and say you're good to go, you're healthy. Then the next day you go out, you get sick, right? So there's no guarantee that all the scanning and things that you do, just because you're good today, means that once you release your application to production, they will be okay. And how would you sort of protect against those risks that maybe you are not aware of that's out there, right? So that's really sort of my focus of the talk. I wanted to sort of take you guys to the right-hand side of that journey. And we can come back and talk about DevOps, right? But for me, I think it's all about adoption, about making incremental changes, right? About making security a shared responsibility. But I don't want to do the dry topic. Let me get into the fun stuff. So, before we get into some of the presentation, we actually did a survey together with Pulse. Went through, essentially interviewing 270 organizations around their process and adoption and their concern about application security. Okay, so it's kind of good sort of cross-functional, and you can see it's not a lot, right? It's not like I think the earlier presentations around the state of DevOps. You got thousands of participants because it's still a pretty new topic. So first question first, right? So what's the biggest challenge of adopting application security? And no surprise here, right? User experience, because you don't want your application to run very slow. You don't want your application to crash in production if it's not happy about the device or the environment that it runs on. Also, I think the big concern for a lot of the organization is this notion of you're gonna slow me down, you're gonna slow developer down, and not everybody's happy. So that's a very, I think that concern is always gonna be there and it's never gonna go away, right? It's how we, as a practitioner, improve those processes and making it incrementally as we go. Now the next one is interesting. So when you look into the application security domain, right, those mobile apps that you guys spend a lot of time develop and release to production, what are the concerns that people have, right? So ultimately, we are worried about data leakages today, right? So how you store, how you transmit data, and I hope some of the developer here would raise a question and said, hey, I follow best practices. I have certificate pinning implemented. So that should be secure, right? I encrypt data at rest. That should be secure, right? We'll find out a little bit more, but it is a concern for most people. And I think the other one that is getting more and more interesting is this notion of third-party SDK. There's a lot of the code that you write that goes into your app, but there's a lot of the code that you don't write, but it's a library that you don't even have source code that you're incorporating into your application. How do you know what those libraries are doing? How do you know what data it's collecting, where it's communicating to, right? So the similar notion of a supply chain concern, right, is something that a lot of the organizations are looking at. Now, in terms of standards, right, I think in Australia, I don't know, because I'm based in Singapore, I see a lot of regulations from government, from financial institutions that sort of focus around how security should be implemented. But there is a standard, right? So the OWASP top 10 for mobile, now it's evolving to Mass VS. I kind of like the way they've laid out, because not every application is equal, right? You don't apply the same security mechanism on the same app. So it's really understand and classifying, and do your threat modeling around what does the app actually do, what data does it collect, and ultimately what security control and measure you need to implement. So it's really good reference guide, right, for anyone who's maybe new to mobile security. Now, when we survey, right, the same people, we actually found out that there's a good adoption, right? 63% of organizations are using some sort of code scanning, right? Static analysis, dynamic analysis, DCAs in their life cycle. And then when we ask the question, do you do anything with the application binary? This is not the source code anymore, right? This is actually the packages that you're ready to go for pen testing or ready to go for releases. A lot of the organizations don't really do that, because they said they take over the binary, they send it over to pen test. Now, why is that important? So let me give you an analogy, because we Aussies, we all love cooking, right? So if you imagine, right, the static scanning, dynamic scanning, and SCA is like when you're cooking the dish, you're checking the ingredient, whether they're really genuine, they're fresh. If it's a special brand, does it really come from that particular packaging? So that's great, right? But what about when the dish is cooked on the right-hand side? How do you get feedback on whether that dish actually tastes the way it should be? It's not too salty, it's not, not overcooked. Pasta should be al dente, right? So the testing that you do today in your source code processes, you probably not really applying to the right-hand side, but you do. Some of the organization do pen testing. So that will give you, basically they throw the dish on the wall and see if it sticks. If it sticks, then it's a good dish, right? So they go through the process. So what I'm trying to say here is, maybe when we are thinking about testing the application security notion, we should really think about while it's cooking, you should taste or test as you go, and not waiting towards the end, right? Because you're over seasoning, you can actually do something, correctively to fix those issues, right? So that's just, again, right, some mindset that, hopefully that give you some idea, right? And there are capability out there that helps you do this kind of scanning during development, right? You don't wait until the end, where it's often too late, because the pen tester will come back to you with all these problems. You'll delay your releases, and that becomes, issue altogether. Okay, so let's move on. How do I do for time? Great. So next question I have is, right, we do a lot of testing, all the X-ray, blood test. Once the app is released, how do you know how the app is doing? Some of you might think, right, yeah, I have instrumentation. I know how many users are hitting my business application, what's the response time and all that. That's great, right? That's what monitoring, performance monitoring, and observability gives you. But what about the security-related feedback and telemetry, right? How about knowing how many people are running your application on the device that's already compromised or jailbroken, right? Maybe they're infected with malware, or maybe they're actually instrumenting and hooking your application in their device and trying to understand how you're communicating with your backend and bypass SSL pinning while they're doing all that, right? So this is the kind of risk, right, that I think when we talked to some of the attendees this morning, they were like, oh, I don't think this was a problem, right? So hopefully that gives you a perspective, but talking is very vague, right? So let's go into sort of show and tell, right? So another survey just before I get into more data point is when we talk to the application owner, right, they obviously have concern. And when we ask them, these are the example of threats that we observe out in the wild, what do you worry about, right? So you're seeing here malware, and you see, phishing. Even though sometimes you think about as a developer, right? You already have a lot of work implementing features and function. Now the business or the security teams are coming and say you need to also look after security. Next thing you know is you also need to check if there's malware on the device. Next thing you do is making sure there's no phishing attack. Your job is endless, right? And the question is is this supposed to be something you do, or there's a better way to solve this problem? Now, come back to the fundamental issue that we are trying to solve, right? So for the last, I would say, 5 to 10 years, when we build mobile application, we have the best practice of building a very secure vault. So basically your app, right, is like a very secure room you build. The house on the right-hand side is essentially the mobile phone where the app is running, right? A simple analogy. So we do all the best practices. We obfuscate the code, we encrypt all the data, and then we obfuscate and harden the actual vault, right? So when the vault is closed, it's very secure because no one can get into it. However, when that vault is installed onto your user's device, when the vault door is open because someone's running your application, then everything is undone, right? Because all the encryption that you apply is now decrypted. All the communication that you're sending, right, can be intercepted or inspected, etc. So the attack vectors are moving away from people attacking your application to attack coming from the outside. So here are some examples, right? People are running outdated operating system. So if you guys use iPhone, I think a lot of you does. A week ago, there's the latest iOS update fixing 2 critical vulnerability that used to be 0-day, but it was patched. So there's always going to be security events and things that just because you're running the latest operating system doesn't mean your device is safe, your house is safe. People are now installing malwares and Trojans and tries to steal OTP code, read SMS messages, even take screen grabs, right? We have seen sophisticated attack and malware that kind of does that to neutralize all the security control you're putting. Because whatever you're putting, once the vault door is open, everything is exposed, and the attackers are from the outside looking in and see everything that they need to see. So, in a very simple sort of summary, today, when your app is publicly available, anyone can go to the public store. They can download your APK file, your IPA file. They can essentially do both static analysis offline, and then they can do dynamic analysis, meaning running the application. And I'm not, really a hacker, but I'm interested in the security domain, right, for mobile. So you can see when Zimperium as a company analyzed over 3 million applications. So these are applications that's publicly available today, probably running on your phones, right? In fact, before I came online, I actually analyzed the top 4 banks' application, right? Just simply run these applications on jailbroken and rooted device, right? And there's no direct mechanism of feedback, right? So maybe it's because rooted and jailbroken is not an issue, or maybe there's just nothing has happened yet, right? But if you look at some of the data, right, there's 81% of application on Android that doesn't have any obfuscation. Are you guys familiar with the concept of obfuscation? Yeah? So I will go into and show you guys what it means. But if you look at this statistic, it's very interesting because I think a lot of the assumption that developer or even security people make is that the devices that I'm using are secure because every application is sandboxed. They're in their own little room. they're locked inside the room. But what happens is that when the house is compromised, meaning the bad guys in the house, getting into your room is just a matter of time, right? I think this is probably the biggest misunderstanding. So there are techniques out there that people would then get into your application, look at the data. They can even bypass all your runtime checks that you are implementing. And even if you do cryptography operation, so how many of you have crypto, like encryption data on the mobile application? Right, you do. So now let me ask you a question. When you encrypt something, you need to have a key, right? And the data you want to encrypt. Where does that key live? On the mobile phone, right? In order for you to encrypt. Where do you store the key? Secure enclave. Sounds pretty secure, right? The key store on the hardware. But those protection works when the data is at rest. But when you are loading those keys into memory and try to decrypt and run the operation, those are in clear text. And this is where the attackers are looking at how you're actually doing your operation and try to find the weakest point and then game over. All right. So now let's go through these examples here, and I want to show you visually what those looks like. And any one of you guys can actually do this, right? So what I'm doing here is not anything special. They're all open source. So core protection. Today you can take any APK file. You can rip it out from your phone, or you can go and download from the APK repository, right? So for non-developer, don't get overwhelmed. It's just a lot of stuff, right? But if you look at this screen here on the left, right, you can see the coding structure. You can see libraries. In fact, my eyes are having trouble. So you can see things in English, right? They are not really protected. They're quite visible. If you look at the right-hand side, I can see, okay, there's some Wi-Fi related configuration code there. There is some API keys there that probably helps me communicate with my backend and things like that. Right? So this is not an Australian app, right? Because I try not to offend people when I'm here. When I'm in Australia, I do the Asian app, and when in Asia, I show the Australian app. So for those of you who want to see Australian app, come to Singapore. Okay, so you can see these are, whether or not, right, they are sensitive or important is, not relevant. The relevance is that you are giving people easy access to the code, the logic, and things that may be useful. And, with security, it's all about time, right? Give me enough time, the bad guy can get what they want. All right, so that's one example. Now, the smart guy in the room will say, hey, I use obfuscation, open source, from Google, right? Aren't they good enough? It's not bad, actually. If you look at the left-hand side, what Google or RA does for your app is it does function and class name renaming, right? So you can see all of a sudden, I don't see Android X and this particular library anymore. I see A, B, C, D. Not very interesting. But it's better, right? Better than nothing. Now, if you look at the right-hand side, even though the classes and the methods are being renamed, the source code is still there. So I can very easily hit the search button and search for AES key, API key, search for things that I'm interested, and still all the information that is still available in your application's source code are still exposed, right? So I just wanted to highlight that, if you are building application that has sensitive logic, maybe intellectual property, maybe things on how you, perform a transaction, a payment transaction, or how you're talking to the backend, because ultimately a hacker doesn't want to do much on the app. I just wanted to open the door so I can get to your backend. The most common issue we see when we're doing this static analysis is all your configuration for pre-production environment. They're also in the application. The pre-production keys are also in the application. Guess what? The developer, the attacker would go to your dev environment because it's probably not protected the same way as production, right? So there's many risks that exposes for a lack of protection. So I know I talk about some of the problems, some of the issues, but the idea is not to scare you guys. There are actually best practices, right? So you do want to obviously apply and understand where are your critical code, because what you don't want to do is you want to obfuscate and protect the entire app, right? Because there's a third-party library there, you probably don't need to do anything. And the more you protect, the slower the application goes and the application gets bigger, right? So you wanted to balance up that security versus performance. And this is where, remember the sec DevOps versus DevSecOps? you want to work with different teams in the organization and understand, right, what are the right things to do, whether they're policy, privacy-related data that you're collecting, that you probably wanted to protect them in a way. You want to talk to the product team and understand what are the, if it's a health-related application, what regulations, what compliance do I need to meet, right? So those are the kind of idea. And just to show you guys some example, if you guys are familiar with CrackMe offered by the MSTG, right? So there's actually an open source document that talks about how to secure mobile application, how to test them, and there's a sample application that's provided by the GitHub repository. And I simply put that application out, right, and show you guys, hey, you can see there are information on the left, which is not obfuscated. So there's some AES encryption here, some keys. So on the right-hand side is when you apply obfuscation to the code, and this is where developer don't actually have to write any code, right? Because it's really just a process you put through a CI/CD pipeline. And you'll see that all of a sudden, all these root detection here, I need to upgrade my glasses. I can't see very well, but hopefully you can see there are human readable English here, right? Root detected, debug, I think, all right? And on the right-hand side, the same application, once it's protected, all these important things that's readable, it's disappeared, right? And that's kind of the goal and the objective you want to do. You want to slow down the attacker and don't make it too easy, right? Why would you leave the key under the mat when they can get into the house where you can actually hide it? Okay, some other example, right? So you see some sensitive API keys here, some data here again on the right-hand side. What's interesting here is that we are encrypting the entire class, right? So that it's hidden within the application binary. So when the reverse engineer tries to do the search and look at, AES cryptography operation and sensitive data, they no longer can find it, right? And that's another technique, right, that you can consider implementing, right? Encrypting the classes versus, obfuscating the code itself. Now, we all do this all the time, actually. Any application that you build that implements certificate pinning will have the certificate inside the application, because every time you ping or you check against the certificate, you want to know this is the certificate I'm validating against. This is the one I trust. And guess what? That certificate is in the asset folder. Attacker can tamper and change that certificate. They can take that certificate and put it into Burp Suite. And now they can actually intercept your traffic as if your application is communicating to the real server, right? So again, things like that wants to be protected. Now, let's move on. The next area is about data protection. So all the code protection example that I gave here, right? The attacker did not even run the application. They just download your binary, and there are tools out there, open source, that can see everything's inside. Now, the data protection is actually when you're running your application, because when you run your application, you can see here, it's in a sandbox environment. Normally, a normal user cannot get in, but because I'm running on the rooted device, and supposedly this device checked for root, right? So it's very easy to bypass. And you can see here, I actually hide all my sensitive data, but this is a COVID tracing application that has, when I took my vaccination, my ID, my passport number, and all that. And where do they put the data? Obviously, it's in the server, in the database, but there's a cache copy on the device itself, right? I think you guys can tell, right? If you, as a developer, if you're not aware of certain things that's happening, these data become risky for leakages. And the attacker is not interested in my own data, right? They're interested in how you call the data, save the data, retrieve the data, and get the rest of it. So the example here, right, is just the common steps that people can go through. They can bypass your runtime mitigation. They can bypass SSL pinning, and these are there's tools out there that can help you do that fairly easily. So it's not easy, isn't it? The developers here, like you have your day job, and then you have all these bad guys, and the tools that the bad guys are using are better than what the developer have today. Now, key protections. So I kind of mentioned that earlier, right? About the whole notion of a cryptography operations that. Back in the old days when the keys are on the server, right, it's stored in the HSM, it's isolated, it's FIPS compliant, there was no problem because it's much harder to get to the server, right, to compromise the server and get the key. On the mobile devices, it becomes a challenge because anything that you do, you store, anything that's in memory can be extracted when the device is in a compromised state. So here's some example, right? So this again, there's references down there, but it's quite easy for you to hook your running application and dump all your API calls to your key store, for example, and all the keys that you store in there are accessible and visible. So you might think, right, what can you do with the key depending on the crypto operation? Again, it's in the source code. It tells you it's AES, ECB with the padding, right? So you kind of do all the work for the attacker. They know what algorithm you're using. You got the key. Then I can take all the encrypted payload and then I can do stuff with it, all right? Not very secure, not very good. On the right-hand side, iOS developer, don't we all love keychain? We just put stuff in keychain. It's safe. And this is on the right-hand side. This is a jailbroken device that I have a few applications installed. I connect it, and I just dump keychain, and all the information just gets dumped in clear text. Some of the application actually store their key even in, like binary, like clear text, and is usable for people to actually take advantage of, right? So the moral story here is that you should not trust the devices that your application is running on, because you should assume that it's already compromised. The bad guy is already inside the house, waiting for the vault to open, right? And you need to sort of design security around that. So now, right, I told you about the problem. I think some of you guys are well aware of this issue because it doesn't just happen on mobile, it happens on your Windows machine as well. If you're root, you can do pretty much anything. Now, so what I wanted to also quickly touch on is this concept of white box cryptography, right? So traditional cryptography on the left, it's about mixing the algorithm and the key together and result in a protected string. And vice versa, you can reverse it to get the original string. What white box cryptography does is when you can take your crypto operations and the key and you put them together, melt it, you kind of I'll use the cooking terminology later, but you put them together so that you cannot differentiate the key from the operations anymore. And ultimately what you end up with is the sensitive data you want to protect and the protected string. So when the attacker tries to attack in memory, they cannot see anything useful. Right? And that's one of the examples of the technique that you can implement. And just put it into the cooking context. It's a little bit like you're trying to protect a secret recipe on the left. You're trying to mask things out. Whereas why don't you just have a pre-mix sauce for your pasta dish? Because I can see the sauce. I can see maybe there's some herbs in there, but I don't know the ingredient quantity. I don't know exactly what it is, right? So that's essentially what white box cryptography tries to do, to secure some of the secret component within your application. Now, I think I got 2 minutes. I think we're going okay so far. So the best practices again around data and key protection is, assume that the device is already compromised. You should always encrypt your data, but be aware what data you're trying to encrypt, where you're storing those keys, how you ensure, right, those are not difficult or not easy for people to reverse and take advantage of. Now, the last bit, this is my favorite actually, runtime protection. How many developers here actually writes their own root and jailbreak detection? You do that? Do you use an open source library, root beer? Okay. So do you guys even do anything about root or jailbreak detection? Is that even something you do? You're laughing, so please. You don't? You have no idea, okay. I think you're probably gonna tell me you're not a developer, so you have no idea. So I think, being a developer before, right, it's very easy to go and Google for, some pattern. You look for compromised devices, you put in your code. And that's what I would probably do under pressure of all the business requirement. Right, so the challenge is that there are new bypass tools for jailbreak, for routing, they're out there. Right? It's difficult to keep up, and as a developer, it's a hard task. And I think the other concept that I want to try to just share with everyone here is that root and jailbreak, you can think about analogy of your house have a lock. You lock the house, right? But jailbreak and rooting unlocks the house. But is that a bad thing? Do you worry more about someone's inside my house, inside my living room, as opposed to the door is locked or not, right? Because there's a lot of emphasis, and we were working with some banks in Asia. They go to pen test. The pen testers always take the latest tool and they try to jailbreak and attack and bypass the check, and it's never enough, right? So it's a cat and mouse game. So what I want you to think about is focus on the actual behavior. They're hooking the application, they're dumping stuff in memory, they compromise the device. Those are the things that are more important as opposed to just purely checking for root and jailbreak. And this is a example you can see. I've downloaded the crack me example. So you already have root detection. Very good. It's not working. I use Magis, the latest version. Press a few buttons, the root detection is now bypassed. Only takes a few minutes, and that works for almost every app on the market, except for some of the few that's protected by us. Okay, now we can share more. I know I need to. My time is up. So really, once your device is compromised, once it's pawned, basically the app is their oyster, right? You can see here that all these API can be injected. On the right-hand side, there's all these bypasses, iOS 11, 12, 13, 14. You name it, you pick it, right? Then these code gets injected into the memory where your application is running, and all the security measurement or controls are now gone. Malware. So I think, given that the time reset, I got 30 seconds. Awesome. So there are malwares out there that are pretty smart, right? Because they are essentially installed on your device, and this is Android user only, right? I'm an Android user, so it worries me more. But you can basically imagine those malwares are sitting on the device and not doing anything until the banking application gets launched. It overlays a fake screen on top of it, where you allow the user to log in with the username and password, reads the SMS, the OTP token. So the user feel like they're actually transacting against the banking application, but in fact, all their credentials are being leaked, right? So there's if you look at all the functions that you can do, right, it's mind-blogging, screenshot, read SMS, hijack SMS, etc. Now, wrapping that up, I got another 1 minute. Is this normal or someone's hacking? Oh, it's done, sorry. Okay, just to finish it off, right, please come and talk to us. We have a booth there, and ultimately the final slide, it's a journey, right? And just make sure when you're securing your application, you want to run faster than the next person next to you. Thank you very much for your attention. Thank you.